Hello friends, welcome on my channel Jagdish Chaubey. This video Heat Treatment Series 2 Part 5 is on nitriding process. So let us see what it contains. So the content, first of all, before going into detail, I'll go for the flashback. Prior to this, I have already produced 8 videos in Heat Treatment Series 1. Okay, all these 8 videos are there. You can read, go through in detail. And this current series, Heat Treatment Series 2, I have already produced 4 videos. First was on introductory part. Second one was solid or pack carburizing. Third, liquid carburizing. Fourth, gas carburizing. And this part 5th is on nitriding. Okay. Let's see what covers. See, in the coverage, first of all, input steel. What kind of steels can be used for nitriding? In this, generally, medium carbon steel is used. And for details, if you want, I have already mentioned here, down below. You can see medium carbon steel, then alloy steel having combination of aluminium, chromium, moly, vanadium, nickel. All these elements are basically nitriding forming element. That is why they are desired. Then there is a series of alloys that is called nitro-alloy steels. These are nothing but aluminium containing low alloy steel. Then you can go for air hardening tool steel also, high speed tool steel and stainless steel. All these steels can be surface hardened by nitriding. Okay. So this is about input steel. Now this is the nitriding process that I will cover, and after that advantages and disadvantages, and finally application. First of all, definition. Nitriding is a case hardening process which increases surface hardness of steel by absorbing nascent nitrogen on the surface when heated in a nitrogenous medium. It means nitriding is a case hardening process in which steel is being heated in a nitrogenous medium wherein nascent nitrogen gets absorbed on the surface of the steel and thereby the surface becomes hard. So this is about the definition of this nitriding. This is the furnace which is a pit type gas nitriding furnace, and the gas nitriding process diagram, this is being shown here, which shows here ammonia gas cylinder is there and there's a flow meter is there and this control valve which controls the flow of the ammonia. It is here and again it is being controlled here, and desired amount of ammonia is introduced into the furnace. This is a nitriding furnace. The lining of this is basically of stainless steel, and within this there is a steel retort. Okay, again stainless steel retort. Okay, in this the part is hanged like this. Okay, inside this retort, and this retort is there and the part is hanged like this, and the gas comes here. Nitriding is done at particular temperature, and after that it gets cooled here, and after that the gas outlet comes over here and it gets absorbed into the water which is kept here. Okay. So this this gas and this gets absorbed here. So this is all about nitriding process. Okay. Let's move further. So nitriding medium, first of all in process, the first thing is nitriding medium. Nitriding medium is, if you see, anhydrous ammonia gas, it is being used here. What is this gas? It's a colorless, non-flammable, liquefied without water ammonia gas. This is being used. Okay. And now the process is of two types, single stage process and double stage process. In this single stage process, nitriding temperature is kept 495 to 525 degrees centigrade. And this ammonia which is introduced, it gets dissociated, and the dissociation is up to 15 to 30%. Dissociation means breaking of the ammonia gas basically. Dissociation is meaning of breaking. So it gets dissociated and the amount is around 15 to 30%. Then it comes the holding temperature at that particular temperature. This is 495 to 525. And if you see 4.1 millimeter case depth, you have to hold for 10 hours. then you can produce this 0.1 mm case depth. And after that, this is being cooled, and then finally it comes here. But when you see the micro of this particular case, then you see a white layer. This is shown here in single stage process. This base structure is there, and in the case you see there is a white layer, and this layer is quite brittle, so it is not desired also. So for that you have to go for a double stage process. In this, you have first of all you have to perform this single stage, and after that you have to go for a higher temperature as compared to the first stage, 495 to 525. You go up to 550, 565, sometime up to 600 also. Okay, and then in this case again you have to maintain this ammonia dissociation up to 65 to 80%. Okay, compared to this 15 to 30, the dissociation ammonia should be around 65 to 80%. And for this reason, you have to use a separate generator for this ammonia. Okay, so that it gets higher ammonia and then it gets dissociated here, and you get around 65 to 80%. So it gets dissociated here, 65 to 80%. Then holding time, again it depends on the case depth required. Whatever case depth you want, accordingly you have to hold. Okay, and it comes out, and you see in this case there is no white layer. Whatever was white layer here, it has been removed or minimized, and you get a nitrided case without white layer. So this is all about this nitriding process. But one thing as a precautionary measure, I will tell you that before nitriding any steel part, you have to do first hardening and tempering of that part. It's a medium carbon steel or alloy steel with alloying elements. So you have to go first, make a base structure of tempered martensite, uniform tempered martensite. Then you have to go for nitriding, because in this case you are not quenching anything. Okay, you are simply nitriding. So with the base has to be strong. On that you have to do this nitriding process. So this precaution you have to take. Major reactions. What are the major reactions which are taking place during nitriding? The dissociation of ammonia, breaking up of the ammonia here, NH3, it breaks into 3 hydrogen and 2 nitrogen. This is a nitrogen which is a nascent form of nitrogen. And again 2 nitrogen, it goes, it's a reversible reaction. It forms nitrogen molecule, and the 2H forms H2. So this is to avoid this molecule formation, you have to do nitriding at a particular temperature for a particular holding time. If you are increasing all those things, then in this case you will not get nascent nitrogen, and thereby nitriding properties will not be attained. So formation of nitrogen molecule and hydrogen molecule is controlled by metering flow of the ammonia gas. So how this is to be controlled? This is to be controlled by flow of the ammonia gas. So this nitrogen, this is the nitrogen which gets nascent nitrogen, which gets absorbed on the steel surface, making the surface hard. Okay. So from 10 hours to 100 hours, it can take for a different case depth. Okay. Now about this diagram, which is down below. This diagram, it shows a relation between HV hardness and depth below surface. Again, whatever hardness, what in this diagram also it shows HV hardness in VPN scale, and depth below surface means case depth. So you can see it says, it shows basically. So it shows effect of nitriding temperature on case depth and surface hardness. This diagram shows effect of temperature, nitriding temperature on surface hardness and case depth. So in this you can see, if you take, suppose I take 0.5, 0.3, okay. If I am nitriding at 500, okay, if I go slightly high this, so the hardness comes around 500. But if I increase the temperature up to 650, then it comes over here and it comes to 400. So it concludes that if you increase the nitriding temperature, you may get higher case depth, but the surface hardness will be lowered. So this you have to balance, that what case depth you want and what is your surface hardness requirement. Okay. So, what are the factors influencing quality in nitriding? Okay, just you read nitriding, wrongly it has been written here. First of all, improper quenching and tempering before nitriding. As I explained in the previous slides, that before going for nitride, before going for nitriding, you have to go for hardening and tempering. So in that, quenching and tempering, all these things are required to be very proper. If it's not properly hardened and tempered, then you will not get a proper nitrided layer, and you will not get a proper property which is required in nitriding, means surface hardness and case depth, etc. Then steel selection, not as per nitriding requirement. Steel also, any steel you cannot use for nitriding. You have to select. I have already mentioned in my previous slide what type of steels you can use for this nitriding. So steel composition also matters. Okay. Surface not properly cleaned. This is a ultimate requirement. Anything which has been nitrided, the surface must be clean. It should be free from dust and other thing. Okay. Then temperature and circulation not uniform inside the retort. If the temperature, means whatever nitriding temperature you are using, if it is not uniform and the circulation inside the furnace is not proper, then there will be a problem in your nitriding and you will not get the proper properties. Other one is ammonia dissociation percentage not as per minimum requirement during first and second stage, that is 15 to 70%. Okay, this is also required. If you are not maintaining this dissociation level, then you will not get proper nitriding properties. Then moisture in the retort due to leakage of cooling chamber. This is also very important. If the cooling chamber has any moisture content or something else, it will also affect your nitriding properties. Improper sealing causing air in the retort. This is also very important. If there is any sealing, if there is any leakage, then the air will come inside the retort and it will spoil your case because it will get oxidized. So nitriding will not be possible, or if it is possible also, then you will not get better properties. Then insufficient ammonia flow may result in shallow case and low surface hardness. This is also for that what you are using flow meters and other things, that you have to give proper ammonia which is required and the proper flow has to be maintained so that you get a minimum low surface hardness. Otherwise you will not get a good surface hardness if the flow of ammonia is not proper or not maintained properly. Okay. Then inadequate preventive maintenance of the furnace. This is also desired because of all this leakages and all this thing. Okay. If this furnace is not maintained properly and there are leakages, then again it will give a very bad quality of nitriding. So you have to maintain throughout. Preventive maintenance has to be done on regular basis so that there is no leakage or other thing. Okay. So these are the various factors which affect, you can say factors affecting quality, or as well as you have to maintain these precautions during nitriding. Okay. So I move on further. What are the advantages and disadvantages? So first of all, the biggest advantage is, since there is no quenching after nitriding, you get no or minimum distortion. Okay, this is the ultimate that you receive. There is no distortion of the part because there is no quenching. Better dimensional control also because of this no distortion and other thing. This is again a mass producing process. You can produce, if the similar parts are there, you can produce in bulk. Increased wear and corrosion resistance and fatigue life. This is also there. When you do this, anything case hardening process, they generally increase wear resistance of the part, corrosion resistance and fatigue strength. Okay, instruments. This is also very advantageous because all the process parameter can be well maintained, and therefore the process parameter is maintained, then you will get a good quality in nitriding. Okay. Parts can be used as nitrided condition or may be finished by grinding, lapping or honing. In most of the cases, majority of the cases, nitriding is done on the finished part generally, because the case depth requirement is very low. Okay, you get a good surface hardness with very low case depth. So generally they are maintained, or some allowances are to be left in the previous process, machining process. In some condition, you may finish it by grinding or lapping or honing. That is also, it can be done after even nitriding also. But in general, it is a final process which is being used in industry. Okay. Then high surface hardness, 62 to 67. See the hardness level. You can achieve up to 67 HRC if you do it properly, okay, with proper control parameters. You can achieve it by controlling proper parameters, okay. And if you compare with the carburizing, this is a good in generally carburizing you get 58 to 62, maybe 63 also, but 67 is not. So in that case, this particular, if you want to have a very high surface hardness, then you can go for nitriding, provided you use a proper composition of a steel. Okay. Now, disadvantages. The cost of nitriding processes is limitation of its use. Because of its equipments are costly, you have to have a good furnace, then we have to have gas generator also, all those endo generators are required. So in that particular case, the initial cost goes high, so it is a kind of a high cost process. Then long cycle varies from 48 to 100 hours depending upon the case depth. This I have shown in the graph also. Depending upon your case depth requirement, cycle may go up 48 to 100 hours also. Okay. High skilled operators required to control the process, because this is a quite technically sound process. You have to keep a skilled operator so that he can maintain all those process parameters like flow, ammonia flow, gas generator, then dissociation of ammonia, then temperature inside the furnace, leakages and all those things. So you need a very skilled operator who knows about this nitriding process. Parts with different shapes and sizes cannot be nitrided together. This is one of the disadvantages, that different shapes cannot be do. You can't do anything in the furnace. You have to have a similar parts or similar shapes. Then you can do it in bulk. But parts with different shapes and sizes cannot be nitrided. Then the last one is high maintenance cost. Okay, overall to maintain this total equipment and all this maintenance cost is quite high as compared to the other processes. So this was all about advantages and disadvantages of this nitriding process. Now application. Used for automotive parts such as gears, crankshaft, camshaft, cylinder liners, valves, bearings and cam followers. All these things they are using. All these things we use nitriding as a surface hardening process. Then dies and tools, extrusion dies, forging dies, then your die casting tools, they are also nitrided for getting a good surface hardness. Applicable to aerospace industries like bushings, piston rings, double helical gear, thrust collar, etc. These are also being nitrided. And parts working at high temperature like injectors and nozzles, because a very high temperature resistance is there, and it maintains the hardness, surface hardness at high temperature. So all these injectors and nozzles are also being nitrided. So friends, I have covered almost most of the things which is required for nitriding, starting from your definition, then equipment, then a process flow diagram, and after that whatever reactions that are taking place inside the furnace, dissociation of ammonia, and the two processes, single and double stage process, how to maintain this dissociation percentage, okay, depending upon that, and temperature difference between single stage and double stage. All these things have been explained to you, and after that, whatever the factors which are affecting your nitriding processes, or you may say even precautionary measures also, that is also being explained. And then advantages and disadvantages of the process, and finally this application of the nitriding process. So I hope you must be satisfied with this presentation. And if you have liked this presentation, I request you to share with your friends, your WhatsApp group, like on my channel, then give your suggestions also, so that I can take it at my future presentation. And if you are new to my channel, then request you to subscribe my channel. Okay? So thank you very much. Thanks a lot.